Welcome back to class. This is Elsam. Today in our UTME course, we're going to be treating this very important and interesting topic, quadratic equations. Okay, so we'll start with the meaning or definition and the standard form of a quadratic equation, and then we move from there. And don't forget to subscribe to this channel to keep getting interesting solutions to mathematical problems. Let's go. So the first question will be, what is a quadratic equation? A quadratic equation is any equation that looks like this. ax squared plus bx plus c equal to 0. Now watch. I said a quadratic equation is any equation that looks like this. So for the equation to look like this, 1, it has the highest power as 2. So if the power is higher than 2, that's not a quadratic equation. And if you have a power less than 2, it's also not a quadratic equation. So you must have this, which we are going to call the leading. Okay, so watch, we have ax squared, bx, c. Now a is the coefficient of x squared. We are going to call the leading coefficient. So watch, a is the coefficient of x squared, and that's the leading coefficient. B is the coefficient of x, which we're going to call the linear coefficient. And c is a constant. So ax squared plus bx plus c equal 0. So this is a quadratic equation, is a polynomial of degree 2. So the highest power of x is 2. So this is what a quadratic equation looks like. And this is the standard form of a quadratic equation. So I believe this is clear enough. So if we see any equation that looks like this, this is a quadratic equation. So another thing to note is that a, b, and c are constants. That is, a, b, and c, these coefficients are constants like 0, 1, 2, 3, and so on. Also, one last thing is that a is not equal to 0. Okay? So a quadratic equation looks like this, a polynomial of degree 2. That one is established. Now, it has the leading coefficient, that's the coefficient of x squared, a linear coefficient, that's b, the coefficient of x, and c, a constant. Now, I've said that a, b, and c, as seen in this standard form of a quadratic equation, are constants, like numbers, 2, 3, 4, not variables. And then our a is not equal to 0. So a cannot be 0 in a quadratic equation. Okay? So based on the explanation I've just given, I'm going to give you 5 separate equations, or 5 different equations. So you're going to tell me whether or not each of them is quadratic. So, state whether or not each of these equations are quadratic. So you want to tell me whether it is quadratic or it is not quadratic. So instruction, state or not each of the following is quadratic. So you're going to tell me whether it is quadratic or it is not quadratic. So number 1, 4x plus 3x plus 10 equal 0. So tell me, is it quadratic or not quadratic? So just state it in the box provided whether or not it is quadratic. Number 2, 5x squared plus 3x plus 2 equal 0. So is it quadratic or it is not quadratic? So let's call this exercise 1. So you can say for exercise 1, number 1 is quadratic, number 2, so exercise 1, so that it's easier for us to reference what you're talking about. So number 3, let's say x squared minus 4 equal 0. Number 4, let's say 3x plus 2 minus 6x squared equal to 0. This is a 2. And the last one, let's say 5x squared minus 6x equal to 3. Okay, so the instruction is to state whether or not each of these equations or each of them is quadratic. So just say exercise 1, number 1 is quadratic, exercise 1, number 2 is not quadratic, and so on. Just state. So you have the time counting. Okay, I'm not going to say the answer. But you just pause it, drop your answer in the comment section, and then we continue. So I will rub this and continue the class, but I'll be waiting for your answer in the comment section. But bear in mind what I said earlier, that our equation is ax squared plus bx plus c equals 0. I said a, b, and c are constants. I mentioned that. And I said a is not equal to 0. I mentioned that. So I think with that, you can tell me whether or not each of these is quadratic. So I'm waiting for your answers, but I'll proceed. Okay, so now we move to methods of solution. So let me just put the standard form somewhere. Ax squared plus bx plus c equal 0. Okay, so this is the standard form. Let me pick an example. Let's say we have x squared minus 5x plus 6 equal 0. So this is a standard quadratic equation. So it meets this condition. Our a is 1, right? So which is not going to be written. So 1x squared minus 5x. So that's it. Now we want to look at methods of solution. Now, there are 4 main methods of solution. One is the factorization. Another is completing the square. Another is use of formula. And then we have graphical method. Now, for the purpose of this class, we are going to focus on just 2, which is factorization and use of formula. Now, why are we focusing on these 2? Because of the exam we're preparing for. Now, the next lecture to this, which we are going to look at quadratic functions, sum and product of roots, we are going to look at completing the square and then the graph. We might not be drawing the graphs because the exam doesn't require us to draw a graph, but we understand the nature of roots and how it plays out in the graph. So for the sake of this lecture, we're going to focus on factorization and and use of formula. And let's start with factorization. Now, okay, factorization. So we're looking at factorization method now. Now to solve, when you solve a quadratic equation, you get 2 answers. And those 2 answers, we call them roots. So when we solve this quadratic equation, we're going to have 2 answers. Those 2 answers are called roots. In the next lecture, we'll look at the nature of the roots. Okay, no, I think we'll have it here, nature of roots here. We'll get to that, but let's just see how we solve first. Okay, now when you want to solve a quadratic equation by factorization, the simple thing to do is, first, our a here is 1, our b here is minus 5, and our c here is 6. Now, we're going to look for 2 numbers. That's what those 2 numbers, when we add them, let's call them x1 and x2. When we add them, it will give us b. And when we multiply them, it will give us c. So, for us to solve by factorization, first we get 2 numbers, x1 and x2, that if we add those 2 numbers, the answer is b. We multiply those 2 numbers, the answer is c. So for us to do that, we'll just get the factors of C. So the factors of C are 1 multiplied by 6 and 2 multiplied by 3, right? Now, if we add 1 and 6, is it going to give us 5? Okay, now we need minus 5. So which two numbers are we going to add to give us minus 5? Or multiply them, it will give us 6. I think that's minus 2 and minus 3. Because if we multiply minus 2 and minus 3, it will give us positive 6. If we add minus 2 and minus 3, it will give us minus 5, right? So the answers are minus 2 and minus 3. So what do we do? So from here, we expand this. So this is the first way. I'll show you another faster way. So we have x squared. Instead of minus 5x now, we have our first one, minus 2x. The second one, minus 3x. Then we continue with our plus 6 equal to 0. So see what I did. The two numbers that we add to give us b and we'll multiply to give us c. Those two numbers, this is the first one, minus 2x and minus 3x. So we broke the 5 into minus 2 and minus 3. Now plus 6 equal to 0. So from here we can group. So group them, group. Now if you look at this, what is common here? X is common, right? We're left with x minus 2. Minus, what is common here? 3 is common, right? If we factorize 3. Here we're left with x. This minus affecting this minus will become, this plus will become minus. And 3 in 6 is 2 equal to 0. And one thing to note is that this first bracket and this second bracket, they would be the same. So we can now factorize again with what is common to both, which is x minus 2. So x minus 2 is common. What we have now here is x and minus 3 equal to 0. Okay, so now if you have a product equal to 0, it's either the first is 0 or the second is 0. So in this case, we have x minus 2 equals 0 or the second x minus 3 equal 0. So from here, x equals to minus 2 becomes plus 2, or x equals to minus 3 on the other side becomes 3. So the solution to this quadratic equation, we have x equal to 2 or x equal to 3. Okay, so that's it. So if you have a simple quadratic equation like this and you have to solve it by factorization, this is the process. Before we continue, let me show you another way I would have done this if I was in the exam hall. Or maybe I'll start that from example 2. So let's just consolidate this knowledge. Let's understand this better. And then I show you that shortcut. So this is example 1. So remember I said you're going to have two answers, which we call roots. And are those roots are what we are getting when we factorize, when we solve the quadratic equation. So let's look at number 2. We'll have x squared plus x minus 12 equal to 0. X squared plus x minus 12 equal to 0. Now, what did I say we would do? This is our B. Our A is 1. Our B is what? 1. Our C is minus 12. Minus 12. So look for two numbers. When we multiply, it will give us C. And when we add, it will give us B, which is 1. So what are the factors of 12? 1 multiplied by 12. We can't get that. 2 multiplied by 6. No. 3 multiplied by 4. Yes. Because 4 minus 3 is 1 for B. And 4 times 3 is 12. So since we need a plus 1, we're going to give the bigger one plus. Because we need a plus 1, we'll give the bigger one this plus. So we're going to have minus 3 and 4. If you add minus 3 and 4, you get 1. If you multiply minus 3 and 4, you get minus 12. And now, get my point. Because we need a plus 1, for these two factors, you will give the bigger one the sign of b. So b is plus 1. So you check the two factors. Which one is bigger? 4. You give that 4 plus because b is positive. So you give that sign of positive to the bigger one. So now our values will be x squared. Instead of this plus 1x now, we're going to have what? Minus 3x plus 4x. Then our minus 12 equal to 0. So now I'm asking you, why did we... Okay, so that's it. So from here, we just broke this 1 into minus 3 and plus 4. But remember, minus 3 and 4, if you add them, it will give you 1, which is our b. If you multiply them, it will give you minus 12, which is our c. So from here, we'll group. What's common here? X is common. What's left is x minus 3. Plus, what's common here? We'll factorize this. We have 4, right? 4 in 4x, we have x minus 4 in 12, 3 equals 0. Now remember, these two are the same, so we can factorize it out. So x minus 3, what we're left with is x here, and this plus 4 equal to 0. So as I said earlier, when a product is equal to 0, it is either the first, which is x minus 3 equals 0, or the second, x plus 4 equal to 0. So from here, x equals to minus 3 becomes plus 3, or x equals to plus 4 becomes minus 4. So x equals to 3 or x equals to minus 4, those are the roots of this quadratic equation. Okay? Before we proceed to the next, I think we need to solve one where the coefficient of a is not 1. So let's look at example 3. Let's solve one where the coefficient of a is not 1. Okay, let's see. Number 3, we have 2x squared plus x minus 3 equal to 0. Okay, so let's solve this one. Now, if you watch, the coefficient of x squared, or the leading coefficient, is not 1, like the two examples we had done. Okay, so how do we solve this? First, we get our AC, which is equal to 2 times minus 3, that's minus 6. You know, in the other examples, we said we are looking for factors of C, right? But now we'll look for factors of this AC, which is 6. So we'll have 1 multiplied by 6, 2 multiplied by 3. These are what will give us 6. Now we're looking for two numbers that when we add them, it will give us 1. Because our A is 2, our B is 1, our C is minus 3. So we're looking for two numbers now that when we add them, it will give us B. When we multiply them, it will give us AC, not just C now, because the coefficient of x squared is not 1. So that's why we're still working with 6, not the 3 that you have there. So take note of this. Okay, so the factors of 6 are 1 and 6, 2 and 3. Now, if you look at this, 3 minus 2 can give us this 1 here. But now how does it play out? We need a positive 1, right? A plus 1, our B is 1, positive 1. So the bigger one, we take this plus. So it will be minus 2 and plus 3. Because if you add these two together, it will give you plus 1, positive 1. So that's why the bigger one is taking positive, which is the sign of B. The smaller one will take the opposite sign, minus. So now if you add them together, you get plus 1, which is B. If you multiply them, you get what? Your AC, which is minus 6. So this is the right candidate for the job. So here we'll have 2x squared. Instead of writing this one now, we'll write what? Minus 2x and plus 3x. Then we'll continue with our minus 3 equal to 0. So, as usual, we group. What's common here? 2 is common, x is also common. Look at it very well. 2 is common, x is also common. What we have left here is x minus 1. Because 2x multiplied by x, that's 2x squared. 2x multiplied by 1, that's 2x. Plus, what is common here? 3 is common, right? What's left here is x minus 1 equal to 0. Now, because we have these two the same, we can factorize it. So we have x minus 1 into what we have left is 2x and plus 3 equal to 0. Now remember, if a product is equal to 0, it's either the first is 0 or the second is 0. So let's pick the first. X minus 1 equals 0, or the other side, 2x plus 3 equal to 0. So from here, x equal to 1 minus 1 becomes plus 1. While here, 2x equal to minus 3. I'm taking the plus 3 to the other side, so it's minus 3. So we can easily divide both sides by 2, so that x equal to minus 3 over 2. So these are the roots of this equation. So our x is equal to x is equal to positive 1, or x equals to minus 3 over 2. Okay, so that's all there is to factorization. So just know your value of b, know your value of c. Now if your a is 1, you go straight, get two factors that multiply to give c and that add to give b. Now if your a is not equal to 1, if it's bigger than 1, you first of all get ac. Now you look for two factors that when you add, it will give you b. When you multiply, it will give you ac, not just c. So it gives you ac. Okay, so with what we've learned, let me do an example quickly. If you don't understand this one I'm doing now, just follow what I've already explained. You're fine. At the end of the day, the point is to get the answer. The point is to get the answer correctly. So let's pick that our number 1, that our first example. We have x squared minus 5x plus 6 equal 0. So I want to do a one-liner solving. Now we know at a point we're going to have two brackets, right? Okay. Now watch. This first term here is the product of this first and this first. So let's call this first last, first last. That's first last for this bracket, first last for this bracket. Now the first and this first, if you multiply first and first, it will give you this first term. So which is obviously x and x. If you multiply x and x, you have x squared, right? Now for this last here, this last term now, the 6. If you multiply last and last, you get this last. So which you can say 2 multiplied by 3 is 6. So 2 and 3 will give you 6. 1 and 6 will give you 6. Now the question is, how do we know which one is correct, judging by how we get this middle term? Now watch you. This outer first and this outer last. So I'll call it outer. That's outer multiplied by outer will give us 3x, right? As this outer multiplied by this outer will give us 3x. That's x multiplied by 3 is 3x plus inner. Multiply this inner by this inner, the inner terms, that's 2x. If we add them together, the answer should give us this middle term. As if we add outer multiplied by outer plus inner multiplied by inner, the answer should be this middle term. So how will this 3x and 2x now give us 5x? It is minus 3 and minus 2. So minus 3x minus 2x will give us minus 5x. So minus and minus. Because why is it minus and minus? So minus and minus. So what we now have is x minus 2, x minus 3 equal 0, right? That's what we have. So from here, x equal... Okay, let me just take it step by step. So x minus 2 equals 0, or x minus 3 equals 0. So x equals to 2, or x equals to 3. But you can get this from here directly. So I believe you get the point. So once you see the equation, if this works correctly, that means it's factorizable. You get this value, you can just get your answer straight. Now, why did we not use 1? Well, okay, why will 1 and 6 not work? Let's say this was 1 and this was 6. Outer will give us 6x. Inner will give us 2x. There's no way this will give us 5x. So that's why that one did not work. Okay, so if you like this idea, drop it in the comment section. I'll stress it more before creating the next video. You know, the next video is still on quadratic equations. So if you like this idea, I'll expand on it. I'll use it more often from our next video. So that's how to solve quadratic equations by factorization. So we'll move to the next, which is use of formula. Okay, so this formula is generally called almighty formula. And one advantage of this formula over factorization is that it can solve all the quadratic equations, whether it's factorizable or not. Okay, so use of formula. So if you have your quadratic equation as ax squared plus bx plus c equal to 0, straight formula to get your answer, your x equals to minus b. You know your a, b, and c. So I'm referring to the a, b, and c in the quadratic equation. So our x will be minus b plus or minus square root of b squared minus 4ac all over 2a. So this one has to be saved somewhere in your memory. Now, like I said, one advantage of this formula over factorization method is that it can solve all the equations. Any quadratic equation can be solved by this formula. But if the roots are complex, you just get stuck when you try to factorize it. So this formula gives you everything. So let's master the formula. X equal to minus b plus or minus b squared minus, that's the square root of b squared minus 4ac all over 2a. Fortunately, this formula was born from the method that we omitted, which is completing the square. So if you solve by completing the square, you arrive at, or you derive this formula from it. But for the sake of UTME, you won't be asked to solve by completing the square. So that's why we omitted that. But we're going to look at the concept in the next video where we go deeper. Okay, so x equals to minus b plus or minus the square root of b squared minus 4ac over 2a. So it's as straightforward as that. So let me pick an example and we solve. Let's solve this one. Question says 2x squared plus 7x plus 3 equal to 0. So this is a quadratic equation, obviously, because we have our ax squared plus bx plus c equal to 0. So this is a standard quadratic equation. So let's solve this using the formula. Remember, our a here is 2, our b is 7, our c is 3. Okay, so x equals to, based on our formula, minus b, that's our b is 7, plus or minus the square root of what's in here, b squared minus 4ac. So b That's 7 squared minus 4 multiplied by A, which is 2, multiplied by C, which is 3, all over 2A. What's our A? 2. So this will give us minus 7 plus or minus the square root of 49. That's 7 squared is 49. Minus 2, 4 multiplied by 2 is 8. 8 multiplied by 3 is 24. All over 2 multiplied by 2, which is 4. 2 multiplied by 2 is 4. So this gives us minus 7 plus or minus the square root of 49 minus 24. That's 25, right? All over 4. So this will give us minus 7 plus or minus the square root of 25 is 5, all over 4. So now let's place the plus or minus now. So our x becomes minus 7 plus 5 over 4, or x equal to minus 7 minus 5 over 4. So we have plus or minus being splitted now. So we have the minus 7, the upper part, plus 5 over 4, or minus 7 minus 5 over 4. So our x is equal to minus 7 plus 5, that's minus 2 over 4, or x equals to minus 7 minus 5, that's minus 12 over 4. All right, is this still obvious? So our x now is equal to minus 1 over 2 if you divide, or x equal to minus 3. That's 4 here, 1, 4 and 12 is 3. So minus 3 or minus 1 over 2. Okay, so that's how the quadratic formula works. It's also equally straightforward. Just get your A, B, and C, and then you solve. Okay, so let's do one more example using this formula, and then we understand the both methods. Okay, let me leave the formula and just get the question. Okay, so let's solve this. Another question. Solve x squared minus x minus 20 equal to 0. Okay, so to use formula, it's straightforward. Our A is what? 1. Our B is minus 1. Our C is minus 20. Okay, so remember x equals to minus B, so which is minus, our B is minus 1 itself. So this is where some people miss it. So we have a minus in the formula, and now your B itself has a minus. So don't conflict it. So follow your exact B. Our B is minus 1, right? Yes, that's what the question says. So minus B plus or minus the square root of B squared, that's minus 1. B squared minus 4 multiplied by A, which is 1, multiplied by C, which is minus 20, all over 2 multiplied by A, 1. Okay, so this gives us same x, minus minus gives us plus 1 now, plus or minus the square root of minus 1 square is 1. This minus multiplied by this minus will give us a plus. 4 multiplied by 1 is 4, multiplied by 20, that's 80 all over 2. So our x is equal to 1 plus or minus the square root of 81 divided by 2. And what's the square root of 81? 9. So our x is 1 plus or minus 9 over 2. Okay, so from here, our x is either, remember, plus or minus 1 plus 9 over 2, or x is equal to 1 minus 9 over 2. So our x equals to 1 plus 9 is 10. 10 over 2 is 5. Or x equals to 1 minus 9, that's minus 8. Minus 8 over 2, that's minus 4. So our x is 5 or minus 4. So 5 or minus 4. So now we know the answers already, but let's just do something funny. Okay, not funny anyway, something interesting. We know the answer now, right? If we were to factorize this, if, let's say, the question came, somebody did his own this way, using formula, and got this answer, x equals to 5 or x equals to minus 4. Somebody else wants to factorize. Remember what I explained earlier, equal 0. So here we have x and x. Remember, if you multiply the first and first, it will give you this first term, right? Last and last, for the two brackets, will give you this last term, which is minus 20, right? 1 times 20 will give us 20. 4 multiplied by 5 will give us 20. 2 multiplied by 10 will give us 20. Remember that. Okay. Now remember that outer plus inner will give you this middle term, which is minus 1. So if you look at the one that can give you a minus 1, is 4 and 5. So 4 and 5. So let's do our outer. X multiplied by 5, that's 5x. Inner, 4x, right? That's x multiplied by 4, 4x. Now we need a minus 1. So minus 1 will be minus 5 and plus 4, right? So minus 5 plus 4, that's a minus 1, right? So minus 5 plus 4. Okay, so from here, equal to 0. Either this x plus 4 equals 0, and the x is equals to minus 4, which you can see from what the other person has done, or this other part, x minus 5 equals 0, or x equal to 5. So it's just interesting. Just play with it, solve it the way you like. You will get your answer. Okay, so we've looked at quadratic equations. We've seen what they are. We've looked at two methods of solution. Remember, I said there's still graphical method, and we still have completing the square method. But our focus for the sake of this class is factorization and use of formula, which we've just talked about. Now, if you look at what we've been solving, we usually have two answers, x1 and x2, which we call the roots of the equation. Now, let's look at what they call nature of roots. Although this nature of roots, we will stress it more in the next lecture when we look at quadratic functions, sum and product of roots. So, but let's talk about it a little in this class. Okay? Now, that's what we'll call discriminant. Look at this formula we talked about. It says x equals to minus b plus or minus square root of b squared minus 4ac, right? Over 2a. This is the formula, right? Now, the content of this square root, which is b squared minus 4ac, we're going to call it the discriminant, d. Okay? So, this b squared minus 4ac, we're going to call it the discriminant. Is this discriminant that determines the nature of the roots of the quadratic equation? So this discriminant determines the roots or the nature of the roots of the quadratic equation. Now, for most of the ones we've solved, we have two answers that are distinct. Now, watch. The first condition is this. If d is equal to 0, you have two equal repeated roots. And what that means is that, well, this our d is what? B squared minus 4ac. So if d is equal to 0, that means b squared minus 4ac is equal to 0, or b squared equals to 4ac. So save this one somewhere in your memory. For equal roots, b squared equals to 4ac. So for equal roots, b squared equals to 4ac. Also happens for perfect squares. So for equal roots, b squared equal to 4ac. So if your discriminant is equal to 0, you have two equal roots. And this applies b squared equals to 4ac. Now, if your discriminant is greater than 0, you're going to have two distinct real roots. Now, remember this example we solved. We had x squared minus 5x plus 6, right, equals 0. Yeah. And then we solved it. Let me just get the roots quickly. So we have x and x. I think here we had 2 and 3 to give us 6. So minus and minus, yes. And then we had x equals to 2 and x equals to 3. Now look at these two roots. They are what? Distinct. That they are not the same. So it says if you have two real roots and they are distinct, that means your d is bigger than 0. So let's see if our d is bigger than 0. Since we had two distinct roots, let's see if our d is bigger than 0 in this case. So how do we get d? Remember, our d equals to what? B squared minus 4ac. So what's our b? Remember, our a is 1 here, our b is minus 5, and our c is 6. So our d is what? B squared, that's minus 5, b squared minus 4a, which is 1, c, which is 6. So we'll have 25, that's minus 5 squared is 25, minus 24. That's 4 multiplied by 6 is 24. Our d is 1. So 1 is bigger than 0. So that's why this is correct. Because it says if d is bigger than 0, you're going to get two distinct and real roots. So that's it. And another condition, if d is less than 0, you are not going to have any real roots. So you have no real roots, complex roots. Now imagine that your d is, let's say, minus 3. Imagine that your d is minus 3. And put that minus 3 inside of this square root. What are you going to get? The square root of minus 3. So let's say your x is equals to, let's say, 1 plus or minus this. Now this is a complex number. Okay, I have a lecture on complex numbers in this channel. So if you're interested in, it's a very interesting field. Very, very interesting. So we treated complex numbers in a particular video on this channel. So you can watch it. So, but the point is that if your d is less than 0, there's no real roots. What you have are complex roots. Okay? So that's that about this first part of the quadratic equations that we have learned. But I want to bring a question quickly, which I have down here, that talks about this nature of roots. Let me bring the question up, or we'll solve it together. Okay, so the question says, for what value of k does x squared plus kx plus 9 equals 0 has equal roots? So the question says, for what value of k does x squared plus kx plus 9 equals 0 has equal roots? Now, our b is not given to us. It's given to us as k. So, but for what value of k does this have equal roots? So remember, for equal roots, I said that what? B squared equals to what? 4ac. I stressed it here earlier. B squared equals to 4ac for equal roots. So that's what we want to look at now. That's what we want to apply. So what's our a in this case? Our a is 1, our b is k, and our c is 9. Okay, so since they have equal roots, b squared equals to 4ac. So our b, that's k squared, equals to 4 multiplied by a, which is 1, multiplied by c, which is 9. So k squared equal to 36. So our k is equal to plus or minus 6. I believe you know How? So k is either 6 or k equals to minus 6. So the value of k for which this equation has equal roots is 6 or minus 6. All right, so we've taken time to look at quadratic equations, and if you have not subscribed to this channel, kindly subscribe now. Now, we're going to stop the video here, bring in exam style questions, and then we solve together. So you see how easy these exam questions are as you have understood the topic. Welcome back. Now we want to solve problems involving quadratic equations. So we've learned all the tricks, and let's solve problems. Now, these exam style problems would tell you the examiner's mindset, how they think, and how or what you would have gotten if this was your exam. Some of them are past questions, like I said. So if this was your exam, would you solve it correctly? So that's what this part of the lecture now would correct. So anyone that you would have missed will get it right here, so that in the exam you get your 100%. So number 1 says, another thing you can do, you can pause the video. Okay, show them all the questions. You can pause the video, look through all the questions and try to solve them. So number 1, 2, 3, 4, 5, 6, 7, and 8. So you can pause the video at this point, try to solve them and see what you'd get. And then after getting your answers for 1 to 8, then you play the video and see what I'll get. Then you can compare. The more you get, the more solid you have become in this. So I think it's time to start. Okay, so number 1 says, if x squared plus 4 equals 0, find x. So x squared plus 4 equals 0. Now we can do this. We can say x squared equals to the plus 4 going to the other side becomes minus 4, right? And then x becomes the square root of minus 4. Right? Now, what's the square root of minus 4? So x will be the square root of minus 1 times 4. X equal to the square root of minus 1 times the square root of 4. Okay? So x equals to I multiplied by square root of 4 is 2. And x equals to 2i. Now, I represents square root of minus 1. So, this is the correct answer. So, the options, A says 4, incorrect. B says minus 4, minus 2. So, the answer is none of the above. Because the correct answer is 2i, where I is the square root of minus 1. Okay? So, that's number 1. Question 2 now says, the solution of the equation is, that the equation is x squared minus 2x equal to 8. Okay, so let's solve this together. X squared minus 2x equal to 8. X squared minus 2x equal to 8. This is the equation. Now we have to look for the solutions to this equation. So we can bring this plus 8 inside, so it's equal to 0. So this will give us x squared minus 2x minus 8 equal 0. Now this looks like our standard quadratic equation, right? And I believe you know what to do, but I will do it this faster way. So I explained to you already. If you multiply the first and the first, it will give you this first term, right? So which is x multiplied by x to give you x squared. Now if you multiply this second and this second, it will give you this 8. So it can be 4 times 2 to give you 8, or 8 multiplied by 1 to give you 8. But you need a difference of 2. So this can give us a difference of 2, obviously. So we'll have 4 and 2. Now because we have a negative 2 here, the bigger one will take negative, the smaller one will take positive. So the bigger one will take any sign that is here. So this 4 will just take minus. So remember, if a product is equal to 0, either the first x minus 4 equals 0, or the second x plus 2 equal to 0. And from here, x equals to positive 4 or x equals to negative 2. We've explained this already, so I don't think we should be wasting time here again. So it is positive 4, negative 2. So correct answer will be option okay. Positive 4, negatives. Okay, this is the correct answer. Positive 4, negative, or negative 2, positive 4. Okay, that was number 2. Now for number 3, this looks like an indicial or exponential equation. It says find the value of x if 3 raised to the power x squared minus 1 equal to 27 divided by 3 raised to the power minus 3x. Okay, so how do we solve a problem like this? So thankfully we've learned exponential equations already. So we have 3 into x squared minus 1 equal to 27. This is the question now. We have 3 raised to the power minus 3x. So this can be written as 3 raised to the power x squared minus 1 equals to 27 is 3 raised to the power 3 over 3 raised to the power minus 3x. 27 is 3 cubed. So let me move it this way because I'm trying to manage the board. So here we'll have 3 raised to the power x squared minus 1 equal to 3 raised to the power. Remember, when you're dividing same number, you subtract the power. So you're going to have 3 minus 3x. Remember this one, there's a minus 3x here. But because we're dividing, we subtract the power. So this minus is for the division, while this other minus is from the power of this our denominator. From here, we can equate the powers, right? So this cancels this, and then we'll go straight. So what we'll have left is x squared minus 1 equals to 3 plus 3x. That's 3. This minus minus gives us plus 3x. Okay, so x squared minus 3x minus 4 equal to 0. So I believe you understand how this became this. You should at this level. Okay, so we're back here again. X squared is product of x and x, right? 4 is product of 1 and 4. These ones are even easy. Because the difference between 4 and 1 will give you 3. So 1 and 4 goes. Now we have a minus 3 here. So the bigger one will take this minus. The bigger one takes the sign of B. So the bigger one will take this minus. The smaller one will take plus the opposite sign. So and that's it. So from here, x plus 1 equals 0 or x minus 4 equals 0. From here, x equals to minus 1. There's plus 1 becomes minus 1 on the other side. Or x equals to minus 4 becomes plus 4. So minus 1 and plus 4. Our answer, minus 1 and plus 4, option A. Okay, so that was number 3. So for number 4, it says given that 2x minus 1 into x plus 5 equals to 2x squared minus mx minus 5. It says what is the value of m? Okay, so this is a straightforward one in my opinion. Well, let's see in reality. So we'll have the 2 brackets. So the question says given that 2x minus 1 into x plus 5 equal to 2x squared minus mx minus 5. I want to find m. Let's expand this bracket. Remember FOIL. FOIL, firsts and firsts, outer, outer, inner, inner, and last, last. So FOIL. So first and first will give us 2x squared. That's 2x multiplied by x, that's 2x squared. Then outer, outer, that's outer, outer. 2x multiplied by 5, that will give us plus 10x. That's 2x multiplied by 5, 10x. Now inner, inner, minus 1 multiplied by x, that's minus x. Now last, last, that will give us minus 5. That's minus 1 multiplied by 5, that's minus 5. Equal to 2x squared minus mx minus 5. Okay, so here we have 2x squared plus 9x minus 5 equals to 2x squared minus mx minus 5. So look at this term, exactly the same. This exactly the same. What it means is that this 9x equals to minus mx. So m itself, 9 equals to minus m. That's 9 equals to minus m. And if you divide both sides by minus 1, m equals to minus 9. So our m is going to be negative 9. Correct answer, option C. So we've done 4. Okay, I think I will do 5 and 6. And I will allow you to do 7 and 8. So I'll do 5 and 6. You do 7 and 8. So let me do 5 quickly. So I think the idea for number 5 is the same for number 8. So if we do 5, then you can do 8. Yes. So I will do 6. Yeah, I'll do 5 and 6. Then you do 7 and 8. So number 5. So what we'll have is 9 raised to the power y minus 4 multiplied by 3 raised to the power y plus 3 equal to 0. Okay? So 9 itself can be written as 3 squared, right? Raised to the power y minus 4 multiplied by 3 raised to the power y plus 3 equal to 0. So we can change this. So we'll have 3 raised to the power y squared. Remember law of exponents. If you multiply these two, if you have a power and another power, you can multiply both powers. So 2 multiplied by y is 2y. Y multiplied by 2 is still 2y. So minus 4 into 3 raised to the power y plus 3 equal to 0. If you look at these terms, they are the same. So we can say let p be 3 raised to the power y. At 3 raised to the power y now, let it be equal to p. We're going to come back here. We're just using this to simplify our work. We'll come back here. So this becomes p squared. That's 3 raised to the power y is now p. So p squared minus 4p plus 3 equal to 0. Okay, so we can do the interesting thing. We factorize. So p squared is obviously p multiplied by p. And 3 is only 1 multiplied by 3 that will give us 3. 3 is a prime number. Okay? So now we need minus 4. So minus 1 minus 3 will give us minus 4. So this one is even straightforward. And now, if we let's do a quick test. Outer items, outer 3 p multiplied by minus 3, that's minus 3p, right? Minus 1 multiplied by p, inner, that's minus 1p. So if you do add them together, you have minus 4p. So it passes the test. And if you don't like this, you can solve it the normal way I've explained. Break 4 into 2 numbers, which is 1 and 3. That's 1 and 3. That's 3. Sorry, break 3 into 2. So 1 and 3. If you add the two terms you are looking for, you will get minus 4. If you multiply them, you will get 3. So minus 1 and minus 3. If you add them, you get -4. If you multiply them, you get 3. So you can use that to break this 4p down, just like we explained earlier. But I think this is an easier and faster one, especially in the exam scenario like this. So remember, if the product is equal to 0, either the first p minus 1 equals 0, or the second p minus 3 equals 0. So from here, p equal 1 or p equal to 3. So 1 and 3. If you are not sharp, you will just pick your answer 1 and 3. Yeah, but unfortunately, these are the values of p. But now we're not asked to look for p, we're asked to look for y. So we introduce p ourselves, so we'll go back to the original y. So from here, remember that p is equal to 3 raised to the power y. So in this first case, our p now, which is 3 raised to the power y, is equal to 1. And in the second case, our p, which is 3 raised to the power y, is equal to 3. So in this first case, 3 raised to the power y equals to 3 raised to the power 0. Remember, anything raised to the power 0 is 1. So this cancels this, our y equals 0. Or in this other case, 3 raised to the power y equals to 3 raised to the power 1. Because 3 and 3 raised to the power 1, the same. So 3 cancels 3, our y equals to 1. So our answer, y is equal to 0 or y equal to 1. So 0 and 1 are our correct answers. So 0 and 1, option D. Okay, so I will do number 6 as the last one for this series. Then I will allow you to do 7 and 8. So after I sub number 6, you zoom in the 7 and 8. So let's do number 6. Remember what I said, this number 5 I just solved, the same idea for number 8. Exactly the same idea. So I'll be waiting for your answers in the comment section. Now for number 6, it says solve the equation. The equation is 10 minus 3x minus x squared equal 0. It says solve the equation. Solve the equation. So we'll just have the options for the roots. And to solve an equation like this is very straightforward. What you can possibly do is, remember I prefer this first one. But going this way might be confusing for a lot of people. So you can just move all these values to the other side so that you have what you are familiar with. So if this minus x squared goes to the other side, it becomes plus x squared, right? Plus 3x to the other side becomes minus 3x minus 3x becomes plus 3x, plus 10 to the other side becomes minus 10 equal to 0. So you can do this easily, equal 0. Now x squared is obviously x multiplied by x. 10 and 3. Remember, 2 times 5 is 10. 5 and 2, you have a 3 there, right? So your 10 can be 2 multiplied by 5. So remember, first and first will give you this first term. Second and second will give you this last term, right? Now, because this is positive, your b is positive, you give the bigger one positive, the smaller one negative. Or you give the bigger one the sign of b, while the smaller one the opposite sign. And from here, because x minus 2 equal to 0, x will be equal to 2. And from here, x plus 5 equal to 0, x will be equal to minus 5. Our correct answer will be option A. Option A. That's x equals to 2 or x equals to minus 5. Now, in case you want to forge ahead with this, the principle is the same. If you multiply the first term and the first, it will give you this first. So what we'll have here is 5 multiplied by 2 to give us 10, or 2 multiplied by 5 to give us 10. Multiply this last and last, it will give you this last. So what we'll have here is x and x to give us x squared, obviously. Okay, because we need a negative 3, this is going to be positive and negative. Now, how do I know? Remember, if you multiply the external and external, that's outer items. Remember, OO plus II I already explained this in the lecture. Outer items plus inner items equals to middle term. So let's go outer, outer. 5 multiplied by x, that's 5x, right? Inner, inner. 2 multiplied by x, that's 2x, right? Because we need a minus 3, our 5 is going to be negative. So that was a mistake. Minus and plus. So 5 multiplied by minus x, that's minus 5x. Plus x multiplied by 2, that's 2x. If you add these two together, you have what? Minus 3x. And this is your middle term. So this is correct. So from here, I already explained this earlier within the lecture. So from here, 5 plus x equals 0. X will be what? 5 plus x equals 0. Move the 5 to the other side, becomes minus 5. Or, 2 minus x equals 0. If you move this to the other side, x equals to plus 2. So the same answer, same answer. All right, so that was number 6. So you will solve questions 7 and 8, and you drop the answers in the comment section. So our next lecture will be on sum and product of roots and quadratic functions. So we'll take it a step higher. Trust me, you would enjoy it. If you have not subscribed to this channel, kindly subscribe now so you keep getting interesting solutions to mathematical problems.